All right, so our goal today is we're going to start with limits. There's three pillars to calculus. There's limits, and then there's the two things that actually do everything, which are derivatives and integrals. You'll love derivatives. Most kids do. Integrals are more difficult, but they get applied more to the real world, so they're really cool. But the reason we have to learn limits first is because they're in the definition of the other two. So although you're going to be going through, well, she said this is calculus is math of the real world. Where in the world would I do this? You wouldn't. However, it's the definition behind the things that we will be using. So we have to cover it first. It's a little abstract. Some kids have a hard time wrapping their brain around limits, but you'll get there. We always do. So first things first, take out your calculator. We're going to get those set up to go today. So if you could take out your calculator, and I'm going to have you do two things. The first one is, if you go to second and hit the window button where it says table set, when you buy them, your calculators have default sets, so if you don't know that and you never change them, you probably don't even know they exist. But when you buy the calculator, it defaults to a delta table, which means change in table of 1. So it means unless you never change that, your table's going to go 1, 2, 3, 4, 5, and then 0, negative, right? Now, if you wanted to do it at halves, you could change that to 0.5. But for our limits, we're going to be putting in stuff like 1,000 and negative 99.9. And that's too hard to do when it's set up like that. So if you move the auto over to ask, what that'll do and then hit enter, it'll allow you to control exactly what goes into the table. So I would leave it there. There's really no need for the other kind of table in here. So I would go move that over to ask, and then it doesn't matter what the change in table is because you'll notice, well, mine has stuff in it, but if you guys go hit second table, it should be empty. Where normally it goes 1, 2, 3, 4, right? So it's empty. It allows you to control it. The other thing I want you to enter is the function that we're going to look at about 5 times today. We're going to look at this rational function. A rational function is a polynomial over a polynomial. So I want you to enter that. If you can't see it, it's also the very top of the yellow page. So we'll go ahead and get that locked and loaded, because if we create all the tables from scratch, it'll take us forever. So I'm just going to we're going to go by row. All right, so are we ready? We've got it set to table, set to ask, and then we have our function entered. And then what we'll do, and if you miss that, again, it's on the top of every page. So in your notes, we're going to start right here. All right, first of all, we're going to learn some limit notation if you don't already know it. And then we're going to apply limit notation to some concepts you already know, actually. So here's the graph of that one. I didn't tell you to hit graph, but you would have seen this. You would have seen a vertical asymptote, and you wouldn't have seen that hole in the graph because it's just, unless you really zoom in, your calculator doesn't show the holes. Does that make sense? So you would have missed that, but algebraically it'll fall out. We are going to do what I call a GNA approach to almost everything in here. So we're going to approach everything graphically, numerically, that just means like making tables and creeping up on numbers, algebraically, which is actually called analytically, and the last one means with words. So if this were a calculus class in college, they focus, I would say, 90% on that guy, which is great because that's actually the meat of it. You'll see tomorrow how it's much meatier than today. But College Board tests you on all of these. So if we used our book alone, we'd only get really good at the analytics, like how do you find a limit? Do you know what I mean? They're going to test you on, can you read a graph? Can you interpret a table? And can you explain correctly with notation what's going on? So we got to cover all 4. That's where this is a little different. AP is different that way than just regular calc. So I told you one of my Calc 2 kids came out of Calc 1 from a college. He's super good at that. But the other stuff, it's, we're kind of trying to build, because I'm like, yeah, but when you take the AP test, you're going to have to do the other 3. So we're going to start that right from today. So first of all, here's the graph, right? So this says, as x approaches negative infinity. So what you're doing is you're going to the origin, you're hopping on the graph, and you're approaching negative infinity. What is f of x, also known as y, approaching? You can see it. What is it? What are the y's approaching as I head to infinity? You can go ahead. You can't hear you guys on here, so 2. Right, exactly. So we're going to put a 2 on here. The notation for that looks like this. The limit as x approaches negative infinity of the function, we need a subject, equals 2. All right, done. That's the calculus notation for the y's are approaching 2 as the x's go to negative infinity. Next up, as x approaches positive infinity. So again, you're going to hop on the graph and you're going to head to the right as far as you can go. And don't hop on over here. I'd hop on over here on the right-hand side of the graph, and you are heading on out to infinity. What are the y's approaching? 2 again. Now, we'll go ahead and write that. Remember, these are y's, so this would be the limit as x approaches positive infinity of the function is also 2. What do you call y equals 2, though? What is that called from your Algebra 2, your test yesterday? What did I call y equals 2? What? A horizontal asymptote. So from here on out, the calculus notation for a horizontal asymptote is not the words. I'm going to ask you the exact same questions as I asked you on yesterday's test. I think there was one where it was the limit as x approached infinity of, and then it had like an x plus 1 or an x, it was something close to that. That right now is the same answer yesterday when I said, what's the horizontal asymptote? What was your answer on the test yesterday? Because 90% of you answered it correctly. What is the horizontal asymptote? Y equals what? Well, yesterday is y equals 0. This one would have had a horizontal asymptote at 0. Its limit as we approach infinity is 0. So now I've got some calculus notation for what you already know how to do. Now watch why ours was 2. Because in pre-calc you learned that to find the horizontal asymptotes, isn't it controlled by the coefficients of those highest powers? And they're tied, so you steal the coefficients and we'd get 2 over 1. Right? So a limit as you approach infinity is really a what? What is it? Go ahead, you can tell me. Whenever I wear these, kids go quiet. What is really a limit as we approach infinity? Horizontal asymptote. Exactly. It's the same process. All right, next step. As I approach negative 3 from the left, so you're hopping on the graph, you're approaching negative 3 from the left-hand side of it. What are the y's approaching? Because the limit is a y value. What are the y's approaching? Looks like the y's are approaching. Yeah, how do you know it's 7/6? If you're like, I don't know where that hole is, how do you know it's approaching 7/6? Exactly, Christian. It says right here the location of that is negative 3, 7/6. So it'd be 7/6. With proper limit notation, here's what you're going to do. You're going to say the limit as x is approaching negative 3 from the left. That little minus sign means from the left. It doesn't mean negative. It means from the left. So if I'm approaching from the left of 4, I'm thinking like 3.999. So that means from the left of the function, needs a subject, equals 7/6. Go ahead and write, if you go in at negative 3 from the right, where do you think you end up? Just go ahead, travel in on the graph, negative 3 from the right-hand side. Where does your pencil lead you? Go ahead. Follow it in. You're pointing right at the dot again, right? So it's also going to be, Harvey, 7/6. So go ahead and write that. With proper limit notation, it's going to look just like this, but you can probably guess how the creators of the notation decided to deal with from the right. Can't you anticipate it? It is a foreign language. You've never spoke calculus before, but you can anticipate why they're going to probably put a what right here? A plus, yeah, because they want to tell you from the left. Now, if you don't see either this guy or this guy, you just see the negative 3, it means from both directions. Does that make sense? So it means you're coming in on your brain from the left and from the right of the function. So we're nodding. So next up, let's go approach 3 from the left. Okay, so hop up here, approach 3 from the left. So I'm coming in, Got to hop on the function, jump the hole, head on, boom. Where do you think the limit is? What? Negative infinity. Exactly. Oops. Ow. Stub my toe. I want you to write that using the proper notation. How do you write limit as x approaches 3 from the left? Just so you get used to it. And again, it should look like this. Limit, you can tell I wrote limit a zillion times today. Calc BC is doing some stuff with limits right now as well, so that's what they tend to look like as the day goes on, as I write them a zillion times. From the left, you put a little negative of the function. Don't forget that. It will be treated, what'd you guys tell me? Negative infinity, correct? By the way, if you forget this guy, it is like, I'm a reader for AP exams, and sometimes one of the points we assign is for student uses proper notation. And if you don't put this here, you won't earn that point. It'd be like writing your English paper and not giving me a subject. Does that make sense? I want to know the limit of what. So if you just write the sleeps, I'm like, well, is it the cat, the dog, the gangle, right? The Gramstead. I want to know. It tells me more about the story. So make sure you put this here. You might say, well, you're being picky, LaRude. If on your test you write limit as x approaches 2 equals 5, you will not earn full points because that's improper notation. It's like writing a paper with no subject. Are we good with that? So and you'll say, well, you know what I mean. I do, but I'm not allowed to give you notational points for that. You might get the point for the 5. So make sure you write properly. And this one, likewise, is going to be infinity, and you know how to write it. So based on what we've seen from the graphs, how do you informally define what the value of a limit represents? The limit is the y value that you approach. All right, you can write that if you want, but just listening to it is fine, right? It's the y value that we approach. So let's go to the next page here, and we're going to, that was graphical, right? We just looked at a graph. Now I'm going to take the graph away, and we're going to do what's called a numerical approach, but I don't think I'll do it for all of them. I just want to show you how to read and make tables. So we're supposed to approach negative infinity, so we're going to go this way. This would be x approaching negative infinity. And then it says to approach positive infinity. So let's go x approaching positive infinity. By row, we'll go row 1, 2, 3, 4, 5, 6. All right, I'm going to assign you one of them. So you're going to go to your table. You already have that function entered. Row 1, 2, 3, 4, 5, 6. And then somebody else in row 1 is going to do that one, and then we'll be able to figure out what's going on. All right, so just go plug it in your table. It should go super fast. Row 1, what happened when you plugged in negative 1,000? Somebody over there tell me. I actually don't know, and I don't want to toggle back and forth between my calculator. So somebody in row 1, go to your table, enter negative 1,000. Tell me what you got. What do you have, Gunnar? Oh, you have that weird calculator. I don't know. The rest of the row, is it 1.995? Yes? NZ? All right, next row. Elaine, what'd you get when you put in a negative 500? What'd you get when you put in negative 500, Clausen? You guys got it? Longer it takes, longer it takes. I have no clue. What is it? Do you have it? Thank you, dear. 1.99 what? 990. And we round to 3 decimal places. Next row 3, somebody got it? Go ahead. Do you have it, home? Oh, yes. What is it? Can someone back that? Yep, I see nods. Next row. What do you have? Can someone back that just to make sure? Yes, we're good. Next row, Caden, what'd you have? And I'm cycling back around to row 1 and 2 for these two, so re-enter. Otherwise, we all have to make the table. That's a pain. What do we get when we put 50 in? Can someone back that? Yep, you're nodding. Perfect. 2.106. And then last row. 052. Back to first row. What's this guy? Go ahead. Do you have it, Cockcroft, in the back? All right. Do you have it, Harvey? Nope. Well, I'm going to quit, but we're going to take a look. You'll be able to see what they approach. If you want to enter 500 and 1,000 on your own calculator, that's fine. But as I'm approaching negative infinity, what does this appear to be approaching? Like if I had a gun to your head, you don't know for sure, to be honest. That's why the tables are the worst. A numerical approach is the least powerful because you kind of have to make an educated guess. But if I had a gun to your head and I said guess, what would you guess we're approaching over here? It's getting close. 2, the same thing that the graph said we were approaching. And on this side, what would you guess we're approaching? 2 again. So the table you kind of need to guess. All right, we don't need to answer that question. We already did before. So we'll do one more table interpretation. All right, so on this one, I've got the same function. You already have it preloaded in your calculator. We're going to now approach -3 from the left. And I think we'll cut it off because actually, once you understand the making of the table, you probably don't need as many. And on your homework, I'm not going to make you make the tables. If you know how, that's great. You should. But I'm just going to give them to you because it's time consuming. And that's one reason I'm not using the book. For these questions, the book had you make a table for every single one of them. And it's just too much busy work. All right? So we're going to share the labor on this one. We're going to approach -3 from the left with row 1, 2, and 3. And we're going to approach -3 from the right with rows 4, 5, and 6. So again, same function. Back to your table. I hate recording, by the way. My morning classes were much peppier because for some reason I put these on and kids go silent. Why do you do that? I don't know. Why? They can't hear. All right. So row, yep. You got one for me? Okay, so we'll deal with this maybe later if I can't figure it out right away. All right, so for now, when I give you the homework, the table's going to be filled in. If you know how to make one, the reading becomes easy. So row 1, what'd you get with -3.1? Benzie? 1 point what? 180, perfect. Row 2? Thank you, dear. 1.168. Row 3? What'd you guys get? Anyone? Thank you, Samantha. 1.167, was it? Okay. Next one. 1.167. Next one. Caden, do you have this one? 1.165. I don't really care about that one because I'm approaching -3. Draw a bar there. What does it appear like I'm approaching? 1.167. Should make sense though, because do 7 divided by 6 on your calculator. Remember that hole was located at -3, 7/6. That's what this 1.167 is about. Again, if we were closer, 1.167, you might want to draw a little arrow like this. It's really approaching 7/6 from both directions. So when you're reading the tables, you make as best of a guess as you can. And I already described what that means, so we're going to move along. I'm moving a little faster because we ran out of time in my other classes. So we're not going to approach this one. We're going to move. All right, so next up, I'm going to do what's called the limit existence theorem. So I'm going to say it just for the heck of it, just because they're right here. These two, he's got a crush on her. Going to ask her out, right? She says, okay. I don't know why. I mean, look at him. No, I'm just kidding. She says, sure, I'm in. Where do you want to meet, right? And he says, let's meet at Taco John's. She's like, don't like Mexican, but I like him. So I'll say, yay, great, right? So they decide to meet at Taco John's. Agreed? And let's suppose you're coming in on 169 from the north, okay? Right? And you're coming in from the south. And you both get to Taco John's. And there was a fire and it's gone. Right? And it's awkward because you're sitting there looking at each other. There's no restaurant. Now what do you do, right? But it's gone. Wouldn't you agree? But are you there? Yes. Have you met there? Yes. The place isn't there, though. Agreed? So keep that in mind. We come in. Now, suppose he's him. You know, what's your name again? Sam. He's Sam, right? We all know Sam's a little slow. So he's like, he said Taco John's, but he accidentally went to Jimmy John's. So she's like, you texted me Taco John's. I came in on Highway 169, and I'm sitting there, and there's a fire, right? And meanwhile, he went to Jimmy John's. Will they meet there? No. That means the limit doesn't exist. You meet there and it's not there, there's still a limit. I'll show you graphically what that looks like. You come in from one direction and you're there, the other you're there. Even if the restaurant blew up, you're there and the limit's there. Does that make sense? But if you come in to Taco John's, blew up, and then Jimmy John's is still there, that's what the graph looks like. That has no limit. So the limit existence theorem actually comes from that analogy. A function has a limit, or it exists. So you're going to write this. The limit as x approaches, let's use c for a constant of a function. By the way, what did I say you're coming in from if there's no plus for right or minus for left? I'm coming from both directions. So my limit exists. And then it's an if and only if from geometry. If and only if. Hopefully you know that means it works forwards, it works backwards. It's a definition. I could write it, I could reverse it, converse it, and it'd be still rock solid. If and only if this happens. But I can't use Taco John's and Jimmy John's on my AP test or in my theorem. So I really have to explain what happened. As I came in from the left on the freeway in this scenario would be f of x. I arrived at the same place as when I came in from the what? Right. How do I write that with limit notation? Well, you're going to write limit as x approaches c from the left. And yet tell me what road you're on, because honestly, if they're on different highways, there's no way they're meeting. So that subject is super important. As I come in from the left towards Taco John's, I better end up in the exact same place as I come in from the right. Here's my question. Does the place need to exist, though? Remember I talked about the restaurant. They're there, but the restaurant blew up. But there's still a limit there. So this guy, I'm going to go now put this on a graph. If this was at 3, 2, right? The limit as x approaches 3 is 2, because I'm there from both directions. Agreed? If I fill in the dot and I say, oh, Taco John's didn't blow up, psych, right? The limit is still what? Where am I? 2. Does that make sense? It doesn't need to be closed, though. Kids goof that up, and it'll be a multiple choice question, and they always choose that the limit doesn't exist at 3. Yes, it does. There's no value there, but there's a limit there. So it's super important for you to understand. Also, you must arrive at, these must be a number. So I'm going to write real number. And that'll come into play in just a second. So here we go. Example A. I'm coming in from which direction? Now you can, this is like a foreign language. You're the only ones in this whole building who have a clue what letter A means, right? Except Calc 2. Agreed? It's a foreign language, but you just got taught the vocabulary. So I'm telling you to come in from which direction? The left of 2, and I want to know where the y's are going. What are the y's approaching as you come in from the left of 2? What would you say? Infinity. Yep. How about as you come in from the right of 2? What would you say? Infinity, right, Sam? Agreed? You can ask her to prom anytime. All right, she's adorable. Just kidding. I'm embarrassing you. What'd you say? Oh, poor thing. All right, so I'm just kidding. I don't even know him yet, and he's so quiet. I'm sorry, Sam. All right. Actually, I didn't even know your name was Sam. I thought your name was Mason. So. Oh, you're Chump. That's why I didn't know your name, because you're not really Sam. All right, so Chump, I come in, I'm sorry. There's something about you that I must just want to pick on you. So anyway, I come in from the left, we go to infinity. Come in from the right, I go to infinity. But what's f of 2? What's the y value there? That's f of is y at. What's the y value at 2? And you should be looking at me with those, your eyes are like, oh, what do you think you write? We're going to refine that because it's easier for us to write D and E, and what does it stand for? Does not exist. So let's take a look at this. Let's talk about limits. Does it look like I'm arriving at the same place? It sort of does. I got infinity and infinity. What do you think the answer is to D? Does the limit exist? What is it? Mm-mm. Where are we? We both came in. Will we ever meet? No. What do you think the answer is? Does the limit exist? No. You might say, but LaRue, I've got the same thing on both sides. Does infinity exist? What is it? Go ahead. If you say it exists, tell me what it is. Yeah, exactly. Never mind to the gazillionth power and then a bunch more times it. Like, you can't get there. It's a destination. It's not a number. So from here on out, when you see infinity, you do not think numbers. What is it? It's a destination, and you cannot get there. And there's different levels of infinity. So if I ask you what's infinity minus infinity and you say 0, I'm like, honey. Right? That's a number minus the same number. Depends on how far you are. You know what I mean? So this is no. And it's because infinity is not a real number. It, by nature, doesn't exist. So when you get a limit that's infinity, what do you think you're going to put for your answer? What do you think? Yes, and then we're going to refine it. So watch. Because infinity by nature doesn't exist, this is how we're actually going to write this. The limit as x approaches 2 of this function is actually infinity. Because it's going from both sides, but infinity doesn't exist. So I'm not contradicting myself, right? It doesn't exist, but we're going to refine it. If you get this kind of a graph, what do you think you're going to say the limit is as you approach whatever that is? Negative infinity. But if you get the split personality graph, that's what we call it as we get going. I'll say, well, it's split. Then you truly write D and E. From the left, infinity. From the right, negative infinity. From both directions, D and E. You got it? So the volcano graph, what do you think its limit is as we approach 0? Infinity, which doesn't exist, so I'm not contradicting myself. All right, next up. Approach 2 from the left. Where are you on the y-axis? Thank you, chump. New chump. All right, as I approach 2 from the left, where am I? Let's go. All right, let's hop on. Where am I? 2. Now I'm going to approach from the right. Hop on the right. Where am I? 2. They are staring at each other in the parking lot of Jimmy John's, Taco John's, which blew up and, by the way, got rebuilt in Otsego. But they're there, right? So do you get it, though? It makes sense. When I told BC when they walked in and they saw this, like, oh, they're starting limits. And I said, yes. And one of them said, I don't remember which girl said, and it blew up. I'm like, you remember. So anyway. So what is f of 2? F of 2 is the defined y value there. It exists. It's 3. Wouldn't you agree? F of 2 is 3. So, negative 3. Sorry, thank you. So does the limit exist? You bet it does. Yup. Where are we from both sides? What's the limit? 2. Right? We came in from both sides and we arrived at 2. So let's go to the next one. Now, we're gonna call this a non-removable jump discontinuity at some point, but for now, we're just reading the graph. As I come in from the left of 2, where do I arrive on the y-axis? Go ahead, Caden. Come in from the left of 2, where are you on the y-axis? Sure, you said, I'm up at 3, LaRue, you're insulting my intelligence, sort of. But it's so important, actually. When I come in from the right, where am I? Negative 3. Doesn't matter that it's defined up above. I am sitting down there. Agreed? Next up, does the limit exist as I approach 2? Yes or no? Read the existence theorem. When I come in from the right and from the left, are they equal and are they a number? They are not. Agreed? So, no. Now, with proper limit notation, if you say we're at different restaurants, that doesn't fly on the AP reading. Or if you say Taco John's blew up, they're going to think you're crazy. I once had somebody there's actually mathematical notation for places in graphs where you get this kind of sharp turn. It's going to be in our chapter 2, which we call a cusp. But you wouldn't believe the things kids were taught for that. We saw shark fin, shark tooth, doink point. Yeah. So kids write things that their teachers say and they don't write them mathematically correct. So you make sure what I say should make things make more sense, but you have to explain it with our new vocabulary. You have to say because the limit as x is approaching 2 from the right of the function is not matching up. Agreed? With the limit. We are at two completely different places. It's not that we're both at the same place. We're at completely different places. So are we good with when limits exist and when they don't? Are you ready? Does the limit exist? Yes, it's right there. Does the limit exist? Yes, it's right there. Does the limit exist? No. Does the limit exist? No, but we're going to call it what? Infinity, which doesn't exist. You get it? All right, we're nodding. Awesome, I love it. Let's go to the next page. All right, so now this is where it gets tricky because I'm going to give you a very higher order thinking thing to do right here. You need to read that sentence, interpret what it's asking you to do. Never happens in math. It's just like this silly little test here, right? You don't have to think it's just numbers. But I want you to read that and draw what it says. Give it a whirl. That'll tell me if you really understand it. Those are the worst test questions when I make you create a graph that meets certain criteria. So you really need to have your poop in a group. So let's split. You're being instructed to make two graphs, and it's as x is approaching a. So let's just throw a over here to the right just to make our lives easy. I'll give you a little bit of time. It's hard sentence to decipher. If you're listening to this video, I'm just walking around, shucking and jiving, right, Elaine? You might have to read that 3 times. What are they asking me to do? Is that open or closed? Read again. Oh, tricky on that one, Christian. So close. I'm going to use him as my sample. Okay, can I steal this? And I forget your name, Blake. It's Blake, right? I didn't forget your name, Blake. So he's sort of got it. I'm going to you have to read really carefully, though. Here's the thing. If you're like, I would never be able, you don't have to draw graphs. What did I just say? On the AP test. On my test, I make you draw them. Because if you can draw them, couldn't you pick out the correct one from 4 out of multiple choice? You know, isn't it a much higher skill to be able to create your own than to pick the right one out of 4 that are there? So if you can draw it, you're definitely going to be able to pick it out. So normally this question would be, which of these graphs does f of a not defined and the limit exists? Does that make sense? And you'll pick the correct graph. So I'm going to use Blake's. He went like this. He did an open dot, which was correct, and then he decided just to, I'm going to go horizontal line. That's totally fine. Right? He's got a function. It passes the vertical line test. Agreed? Anyone do something that didn't pass the vertical line test? You broke the function, correct? And he left an open dot. So I don't remember, but one of you, I said, is that opened or closed? I said, read again. It says, draw and explain. In both graphs, f of a should be undefined. So that's why you can't have a solid dot there. But the limit exists, correct? Next one, he drew this. I better not arrive at the same thing. So again, he liked that horizontal line to the right. What's wrong with his? It's so, and I said, oh, so close. What's wrong with Blake's second one? The limit does not exist. What's wrong with his? Yeah. Now, Christian, I said you had a very different graph, but it was still correct. What did you draw? And I think some of you over there did too. What did you draw? Yeah, he did like a asymptote there. Well, that's great because we're not defined there, correct? And the limit doesn't exist there. So anyone else do asymptotic behavior for the right-hand one? I saw one. Was it you? I know I saw one on that side of the room. So now we're just going to practice interpreting. Are you ready? The type of function it is really important because charts are terrible. What did I just say? Charts are terrible because it is kind of like, what's your guess if I had a gun to your head? If this just said of a function, this would be really hard to ask because it looks like I'm approaching 1, doesn't it? But I have no idea. Maybe there's an asymptote right here and I'm actually going to infinity, and so we don't know. But when it says exponential function, that's a parent function. We did one of them. We did e to the x. Do you remember what it looked like on your test? I had you draw it. What did e to the x look like? Those of you who drew it correctly on your test. Go ahead, somebody over here. Lindsay. Yes. Here's an exponential function. Agreed? But do you ever lift your pencil when you draw it? Like, are there ever any domain restrictions? So you can assume it sails through everything. Does that make sense? It's Savannah, right? So, or if it's exponential decay, it could look like that. Or if there's a negative in front, it could flip over. But the point is, one end goes to an infinity. Agreed? And there's some sort of horizontal asymptote, and I don't lift my pencil. So knowing it's an exponential function allows me to be much better at interpreting the table. So watch. Do you think, based on this numerical table, that this table would best be represented with the blue exponential growth or the red exponential decay? Which one do you think would probably best suit that graph? Blue growth or red decay? What do you think? Red decay, right? You're whispering it, but you're correct. So this is be like kind of thinking of the red graph. What is my limit as I'm approaching negative infinity? That way. If it's exponential, I'm 100% sure it's going to what? Infinity. If it didn't say it was an exponential function, that's where I'm like, I think it might be infinity, but maybe at negative 10 it went way down. You know what I mean? I'm not sure. Next up, as I'm approaching negative 3 on the red graph, as I approach negative 3 from both directions, and it's the exponential function, so I never lift my pencil. Where am I? According to that table, as I approach negative 3 from both directions, where am I? 9, only because I know that I wouldn't be lifting my pen. I have to arrive at 9. There can't be a hole in an exponential function. Does this make sense? All right, answer part D. What does that appear to be approaching? 1. And you might say, well, shouldn't it be approaching 0? It might have been 2 to the x plus 1. It actually couldn't be 2. It'd have to be like something less than 1, right? Because it was decay. Awesome. All right, so next up, a rational function. A rational function is the polynomial over the polynomial. Their behavior is weird. They have some holes, like this one that we just did on your calculator was a rational function. Remember, you entered a polynomial divided by another one. Agreed? And it had a hole. What else did it have that was weird? You can go back. It had a vertical asymptote and what? Horizontal. Some of them have slant asymptotes. They're very weird. So these are the ones where you kind of have to really think about what's probably going on. As I approach negative infinity, so that would be this way, what does it look like I'm approaching? You really don't know for sure. You have to just kind of, if I had a gun to your head, you would say the y's or the f of x appears to be approaching. Good. I won't pull the trigger, right? As I approach negative 1 from the left, now you have to think about it. You don't write D and E necessarily because it's a one-sided limit. And you need to look at the left and the right. Take a look. What does it look like it's doing from the left? It's way up at what? 2001. But on the right, it's way down. It's a rational function, which probably means, what do you think there's happening at negative 1? There's a vertical asymptote. I'm not sure though, Christian, but you know what I mean? The table's numerical's the worst. But I'm thinking I've got an asymptote here, so what do you think I write right here? What does it look like it's going to? Go ahead and tell me what to write. Nope. If I've got an asymptote, it won't end at 2,000. What do you think? That's what that number's close to, but I have to kind of think of what might be happening here. What do you think? Infinity, exactly. Now, you didn't say D and E, which is good, because if you go up, infinity. If you go down, negative infinity. It's only D and E when you do one of each, correct? All right, let's try another one. What appears to be happening, I want to approach 2. Where's that one? D. Remember, as I approach 2 from both directions, the next thing I would have entered was 1.9999999 and then 2.0000. Do you see how these are very much alike? Agreed? These were not. This is telling me up, down. This is telling me I'm arriving at the same spot, but that spot is gone. What do you think there is on the graph of that? A hole in the graph. What do you think your limit is? We're not sure with these charts. It's your best guess based on good math analysis. What do you think my limit would be? 1/3. It appears like I'm really creeping in on 1/3 from both directions. All right, just to make sure that you get why I put infinity, what do you think that one's going to be? -1 from the left. Negative infinity. Now watch this. What if I said limit as x approaches -1 and I didn't have a plus or a minus? D and E. Got it. Right? Does that make sense? So I'm going to have you guys try something really quick. Go, not this one. Yep, actually let's try this one on your own. Look at that graph and try answering the ones on the next page while I pass this out. The questions are on the page next to it. So actually be easier. Let's skip ahead to the one where they're piggybacked. Let's go to this guy. Looks like this is the one I did this morning too because my writing's on it. What page is this one on, guys? Go to page 18 and fill in the first 3 of those. Just want to make sure you can read a graph and a table. I posted the key to this, by the way. This one's due tomorrow, and you might say, what? It should take you 15 minutes. You don't actually have to do anything. You have to interpret tables, interpret graphs that are already made for you. But I do want you looking at the key. First 3, just to make sure we're... I'm only going to give it 1 more minute because that's all the time I have. Again, you're looking for the y value that you arrive at as you approach from towards the number from the direction indicated. If there's no direction indicated, you're coming from both directions. And I got to go through them because it's almost time to go. I just did a chart. I want to make sure I do a table with you, a graph with you. As I approach -3 from the left, I don't come from way over here. Remember, like if I was making a table, I'd use -3.00001 gives me the best. So I get really close to -3 on the x-axis. And what y value do I arrive at? 0. How many of you had 0? Most. Awesome. As I approach -6, from which direction? Both. So I hop on really close, and I go in from both directions, and it actually equals f of -6. I'm right there. What's your answer? -4. How many of you had that? Awesome. Next one. As I approach -1 from the right, so from the right-hand side of -1, real close to it, what y value did I arrive at? 2. Last up. Go try one that ends up being, I want you to approach 4 from the left. Where is that? E. That's a very weird, just want to make sure you know what to write. So you're coming in really close from 4. 3.9999999999999 would be the most accurate, sort of. What do you arrive at? I just saw someone look at me like this. What do you think the answer is? What do you think? I'm trying to approach from 3.99999. What do you think the answer is? I heard negative infinity mumbled, and I heard D and E mumbled. Is this indicating going to negative infinity? No, it stopped. So when I come in from the left, nothing's there. Wouldn't you agree? So what is it? D and E. From the right, what do you think it is? Negative infinity. So you won't get it. They won't trip you up with something like that, but I did. All right, that's due tomorrow. It should take about 15 minutes. The one I give you tomorrow takes a lot longer, so we all get 2 days. But this one, see you later. Just 1 second.